He's waiting, he's keen already. We're a bit overdue, aren't we, boy? Hey, look out, step back. You ready to film another episode of the Deutzenbarge? Yeah? Say hello to your friends. Tell me a story. Tell me a story, Bailey. Tell me a story. Tell me a story, please. You gonna tell us a story today? No, no. Tell me a story. Say good morning.
Welcome to the Deutzenbarge.
G'day everybody. Back for episode number 2 of the Deutzenbarge. So I know you all want to see him. Bailey, say hello to all your fans. He's a good puppy dog. Hey, good boy. Good boy. Okay guys, so what I'm going to talk about today is the design. This dog's between my legs. Is how I come up with the design and everything of the Deutzenbarge. Obviously something sort of never really seen before as far as I know, like with the full drop chassis and everything. Riding on airbags. When it's bagged out, it'll drop down to the rails will be on the ground basically, so that's 230 millimeters clearance at the moment. And so yeah, some of my objectives with building this thing was I pretty much wanted it to be a proper scale hot rod. I didn't want it to look mismatched or anything else like that. I wanted it to be low, very low, like a traditional hot rod. Airbags was sort of a little bit of an iffy thing. I wasn't sure whether I was going to go with airbags at the start, but I thought, well, airbags, you know, you can adjust the height, it's going to ride well. And so that's what I went with. Yeah, I don't know what else to say. Building a car. I've had a lot of people wonder about the strength of this whole thing, which is fair enough. I mean, you guys can't see what I can see, but what I can see, even not complete, is just really solid. So the main chassis rails, they're 180 mil tall, 180 by 75 mil wide. They've got a 7mm web in the middle there, and these flanges are 11 mil thick, so it's not just a bent U-shaped piece of steel, it's actually parallel flange channel, which is a structural steel used in buildings and all that sort of thing, you know. So it's, I think it's grade 300, so it's not just weak little flimsy channel as most people think. The end plates of the chassis, they're a 6mm plate inside and out, and then we've got on the rear I've got 5mm capping on the top and then 6mm capping to the underside. And what you can't see is that this plate here is actually one big plate that goes into the rails there. It goes all the way down the back of the rails here, then it goes across here and back up around. So that's one big structural cross member basically. Have a look at it from the back. It's a bit hard to see without good light, but that's one big piece. And then that integrates into the lower caps on the very rear of the rails here. Sorry about the lighting guys, that's something we'll have to work on. So yeah, on each end of that 180 by 75 parallel flange channel, what I've done is I've got these 6mm plates which I've plasma cut inside and out, and then we've got a 6mm cap on the top here. So all 4 of these, I'll just move this, they will all be welded all the way along there, and then along there, inside and out, as well as all the way along the underneath edge, inside and out. And then also the engine mount's going to go under there, which is going to provide more sort of structural capping over that. And then once we've done all that, we're going to put a fish plate on the bottom of each front corner here, which will wrap around under the bottom of the rail as well. So I've got no doubts about how strong that's going to be. Not welding across the rails at all to create any weak points. I'm only welding along the outside edges of all 4 corners. And then there's also fish plates here and there, you know, to help strengthen it all up. So as far as the squeeness strength goes in the front end, this big plate that goes across the bottom, that also is one piece that comes all the way up along both the rails. And it did have a piece in between there which I had in initially just to keep it all square. So that large 6mm plate under the bottom I had profile bent to fit underneath the rails here, and then that goes up against the parallel flange channel down at the bottom corners there, which is the big fillet weld in behind there. And that's also going to have a fish plate going around that bottom corner under the rail as well. So I don't have any concerns about the strength of it, to be honest. Other people may, that's fine, you know, but and I'm not a structural engineer either, so I'm just doing things to the best of my ability, I guess. So you can see here, I'm going to weld along there first, which will weld this cap to the rail, and then weld along there another run, which will weld this outside plate to both, and then another run of weld along inside and out on those as well. These will all be fully welded, bottom and top, and then we're going to do a little fish plate around the bottom of that corner, I'd say. And yeah, as I say, all welded along that bottom corner, so that should be plenty good in my opinion. The front suspension mounts, that's all 6mm plate, all profile cut, braced in basically every way that you could think possible. That's the engine mount plate that's just sitting in there. It's got to come up and go in there eventually once things are finalised, but still considering different engine mounts yet. And these will all be welded all the way along the corners of the rail, top, inside there, outside here, inside there, outside, and then inside as well. So they're not going anywhere. And once they're all, what I'm going to do is actually slip those off the rails yet, clamp them onto another piece of channel and weld them all fully while they're off the vehicle. And then I'll put them back on and weld them onto the rails themselves. So the rear end is similar to the front, where we've got the parallel flange channel going right into the corner, it goes all the way to the back of that. And then 6mm plate inside and out. I've actually just put a 5mm cap on these rear rails. I thought that was adequate. So there's a big fillet weld down in that corner holding this channel to this big plate, and then eventually I'll put a fish plate around the bottom there as well. But some people are worried about the transition from here into this channel. Now, if you have a look at that, that's 450mm overlap, this plate here, sorry about that. Where it overlaps the main channel, that's going to be welded all the way along the bottom. This will be welded inside out there as well, all the way around the whole perimeter. This big plate on the rear is the same as the front. It's one big plate which has been profile cut to shape, and it comes up Actually extends up inside the rails there on both sides. And then this fish plate finishes it off at the rear, if you can see that. There's a bit of glare shining in, but... And then that laps onto down there. And yeah, I think, I don't know, I might be wrong. I might be wrong about a lot of it, but in my engineering mind it seems pretty well right anyway. So still going to be another plate that goes in here, comes out around here, and it'll lap over the top of that once that's all welded as well. Now another thing to point out is this isn't just in this area, like the stress point isn't just in this area. Having this falling bracket underneath here as well, and that's going to be welded to that, will transition the whole join into the chassis rail a lot nicer, in my opinion. As you can see, it'll be the same on this side. That'll all be fully welded. Everywhere it's all going to be fully welded. And then that transitions into here, which transitions into the rail in my, that's my engineering mind anyway. Still got to put in some more plates that are going to go on the outside here. That's just all sitting there at the moment. So there, these huge falling brackets will be braced back to the chassis rail as well. And I'm probably going to put in a gusset at the front end here as well somewhere. So the reason I've built it like this with the low rails is obviously passenger room. I wanted the cabin to be down low, as with the picture. And that's the plan I wanted, and that's the plan I'm sticking to. So, okay, with the front end, what I've done is it's a leading falling setup. Leading link falling setup. You may notice that I've got the bars staggered as far as their pivot locations are. That's to sort of put the center point of the mount of the whole assembly within the center line of the axle, or close to the center line of the axle. So the airbag's going to be sitting right here. And we've got one rod sort of behind the front axle and one rod in front of the front axle, so that'll sort of distribute the load a little bit. They do look like they're the same length, those bars, but the top bar is actually 50 mil longer. And when it swings up in the full 230 mil of travel, it actually comes up really nice and level, so that's good, and it comes up straight in line with that Watt link bracket in the middle. So that cross member, that's a 6 mil box cross member that I made. It's got the same bush in the center pivot there as what I've got for my main suspension links. I've got 3/4 inch heam joints in the top and the bottom there. That's all tacked together, and of course I'm going to put another shear plate on the outside of this as well. Yep. Front suspension bracketry. Still got I'm going to add in another bit of angle that bolts onto the underside of the I-beam there, and that'll also bolt to the front, to the back side of this with another plate in there, sort of thing. So that should be well affixed to the axle in the end. And yeah, there's still a bit of gusseting and stuff like that to go in. So. Yes, Lena?
Look at the kitty and the doggy.
Oh, look at that. They were living in perfect harmony. So yeah, talking about that, the front end here. So I looked at all my different options. I thought about panhard bars, I thought about a normal Watts link. A few months ago I was actually just on the internet and I seen a high left forward drive vehicle with a horizontal Watts link. I had never utilised one for anything that I'd built in the past, and so I thought I'd do a little bit of experimentation. And what I found is that it actually worked really well. I did a little simulation with some Lego. Surprisingly, you'd think Lego, but no, Lego's bloody handy for any sort of engineering testing and all that sort of thing. And it worked out really well, so I thought, well, that's probably my best option for this, is the horizontal Watts link. And it allows a full 230mm of travel, so when this drops right down, that link's almost just on top of that front axle. Like, I mean, it doesn't need to have much clearance. Once it's dropped down, it's not going to be moving because the rails will be on the earth. So as long as nothing's hitting directly against each other, it should all be fine. Initial travel checks sort of showed that everything works good. The bars clear the rails and all that sort of thing, and should allow the full travel that I require. So yeah. More about the rear end. So it's a trailing 4-link setup as well. A lot shorter bars on the rear. I wanted to allow as much cabin space as I could. These are basically going to be underneath the rear seat, so it is going to be a bit cramped in the back for seating space, but you've got to do what you've got to do, I suppose. I only wanted so much sort of arc movement of the diff as it comes up, and with those length of bars there, we're probably going to be about 30mm of arc difference by the time it's up at full travel, which is not too bad. I would have liked to have had less, but near impossible without having the bars up higher and impinging into the cabin space too much, sort of thing. The diff's got to go back another 30-40mm so far from where it is there. And yeah, what I'm going to do in the rear end is most likely a horizontal Watts link, the same as the front, but I'm going to actually run the pivot probably off the top of the diff, and then have bars coming out, maybe out underneath here, or I'm not 100% sure, or even mounts up over here yet with bars. I'm not 100% sure about that. I've still got to have a bit of a look into it. So one of those things, it takes many hours to sit down and think about how this is all going to work, you know, but yeah, I think we're making pretty good progress. And while it's been raining the last few days, I haven't been able to do much filming and stuff like that, so I made up these plates. These are going to go on the top and the bottom of the diff, and I've got some brackets I've got to make up for those yet and everything, so hopefully it won't be too far off, and actually most of the suspension will be sort of bolted into place. And I reckon, you know, maybe another month it'll actually roll on its own, under its own weight. So that's pretty exciting. Been a pretty decent road to get to this point. And here's Talina. Yes? Oh, very good. And building a puzzle. While I was just coming inside, I thought I'd show you a bit of my background in engineering. There's another part-time gig. I designed Lego sets for the market. There's a couple of my Lego sets that are actually in production and available around the world now. The Harley V-twin and the supercharged V8. This is something that probably a lot of people think, oh, Lego, you know, that's for kids, but Lego is actually a really good engineering tool. All of these models are all fully functional. Steam engine, 2 different Harley engines there, Ducati V4, Rolls-Royce Merlin V12, Ford 427 Cammer, Lamborghini V12, RB26 twin turbo, LS with a high rise, supercharged V8, Chevy V8, the high bypass jet turbine, Chevrolet R07 NASCAR engine, Ferrari 458 V8, and the Chevy with a blower. And then this one up here, which is a bit of a wreck at the moment, that's actually a 9-cylinder radial. So these are all fully functional Lego models. And I'll just show you one quickly. So they've got all the pistons and everything, valves work, rockers, the whole lot. And I've designed these just using regular Lego components. And I'm hoping that they'd be more of a thing that'll be seen as an educational tool around the world, you know. These days it's very hard to get accurate engine model kits. And Lego ones had never been done before, so this was my time to sort of do something. A few of these kits are available from lesdiy.com or Engine DIY Shop. They're back outside, away from the Lego. Everything that I do here, guys, it's basically any man could do in their own home garage. You know, besides the welding's going to be a bit of a big one. I'm going to have to get myself a new machine because there's a lot of heavy welding. This old girl here, it's done about 15 years of use. Really hard continuous use, you know, so we might have to get a bigger welder before we finish welding all this out. But besides that, all the fabrication's all done in-house. I hand cut every single plate with the plasma cutter. I made up some stencils for doing that. A lot of the straight line cutting is done with a 5-inch grinder and a 1mm cutting disc. I find that, like all these plates for instance, they're all cut with a 5-inch grinder and a 1mm cutting disc. Even though it's 6mm plate, you take your time and you won't have a drama at all, but you know, you get really nice straight cuts straight off the bat and no finishing. See, they're all grinder cuts. Any of the straight edges just about that you see are all grinder cuts. And for the curved cuts, you know, we get out the little plasma cutter CIG unit, and that's been a great little machine so far. So yeah, all my holes, you would think, oh, he's got an industrial drill press or something. Now I've got an old piece of junk, and I start off with a 1/4-inch hole, and then I use a step drill, surprisingly, to drill out to 18mm, and then I use a 19mm drill to finish those off. So talking about the drilling of all the plates, that's my old pedestal drill that just died a couple of days ago. Belts, need some new belts and stuff, but I will revive it. But I got this little Azito 13mm chuck unit, and surprisingly it did a good job. That's the step drill in there, an 18mm step drill. So all them holes are 3/4 inch in them plates. I drill them out to 18mm with that. Here's a little bit of the oil out of the Treflex. Seems to cut really well actually, and makes a big mess of course. Last night there was a torrent of rain coming through here, so got a bit of a mess from last night. But yeah, it's surprising what you can do with just cheap basic tools and get a good result, you know. I've got a lathe here. Sorry about the mess of course again, but I've just moved crap everywhere as I could last night while it was raining. So this is actually a mate's lathe that he's just left it here for me to use and for storage sort of thing, which is handy for me. So any of the parts that I need to make, I can make up on this. Any of the tubes or any stuff like that I need to machine. We've got a bit of gear. So we don't want to bore you too much, but I hope you enjoyed what you've seen today. Next week, I suppose, I don't know what we're going to do next week, but yeah, anyway, we'll keep the dream alive and just keep pumping along. Keep building what we can. Here's Bailey. And yeah, thanks for your interest, guys. It's really good to see so many people have taken such a great interest in my project. And yeah, see you soon. Cheers.
What do you call a flying monkey? A hot air balloon.
I love this girl.